Here's a problem that we're trying to solve. Press pause and have a quick read. So it says that we have an arithmetic sequence where the first term is -8. The sum of the first 20 terms is 790. We've got to find the common difference. We've got to find the 28th term. We've got to sum up the first 28 terms. And we've got to find a value of n where the sum just exceeds 2000. So let me summarize what the question is asking. Our first term is -8. It's an arithmetic sequence, so it jumps up by a common difference. And when you sum up the first 20 terms, it comes up to 790. Our job is to find these four, the common difference and so on. So let's try and develop a way of when someone gives you the nth term, you can work out this value here. So if it's what is the second term and so on. So you start out with -8. Because it's an arithmetic sequence, it jumps by the common difference. So if you want the second term, then you jump by one once of a difference. So that would be n minus 1. Because let's say n is 3. If you want to know the third term, you jump twice n minus 1. Look, 1, 2. So you start out with -8 and then you jump the difference one less. So if you want the third term, 3 take away 1 would be 2, so you jump twice the difference. So you start out with -8, you jump twice, 1, 2, and so on. So this is our formula to work out any given term. Once we know the common difference, we've got to work out the common difference. So it says that in the question it says that when you sum up the first 20 terms, it comes to 790. So I'm expecting you to know these two formulas. So when you sum up the first 20 terms, so that would be S20. So S20 equals, the n will be 20 because we're working with the 20th term, n over 2. Remember, we're trying to find the common difference here. And then the first term will be 2 times A1. A1 is -8. Because it says the first term is -8 in the question. And then plus n minus 1. 20 minus 1 would be 19. Would be 19. 19 times the common difference. So that would then give us this. The n here would be 20. So we can put 20 into here. 20 in here. 20 into here. And remember, it says that when you add, in the question it says when you add up the first 20 terms, it comes to 790. So you can put that into here, 790. So this thing here would be the number 10. 20 divided by 2 is the number 10. And remember, we're trying to work out this d here, the common difference d. So divide both sides by 10. So that will then give us 79. 79, and then we don't need the square brackets, so that will then give us this thing here is -16, and then you want to get d on its own. Add 16 to both sides, that will be 8095. 19d. What is d, the common difference? Well, jump to a calculator, and I've done it earlier. D equals 5. So our common difference is 5. So our sequence is actually doing this. It's adding 5 each time. Add 5, add 5. So the first answer would be 5. Okay, and then hang on. Because we know our common difference is 5 each time. We know our formula here. We can put 5 into here. So now we have a formula to work out any term. If you want to know the 28th term, so this will be a 28th term equals -8 plus 1 less, which will be 27 times 5. So 27 times 5, that I did it on the calculator earlier, and it comes to 127. Okay, double check on that, I might be wrong. And then if you want to sum up the first 28 terms, you can use this formula here. It says that if you want, get your first term, which is -8, and then add it to A28, which we just worked out. This is A28. A28 happens to be 127 divided by 2 and then times n. Times n. N is 28. And then that will give us the sum of the first 28 terms. Okay, so that will then give us this thing here. Jump to a calculator. I think it comes to 1386 if you were to punch this into a calculator. So the good thing about this formula is that if you're trying to sum up the 1 up to 28th term, then get the first term, add it to the very last one, and then divide it by 2 and then times 28. That's what this formula is saying. So you need to know the first and the last. Anyway, the last question here. We need to use this formula here. We're trying to work out n in such a way that the sum must exceed 2000. So let's just set it to 2000. So that set it to 2000. We'll try and work out the n that would give you 2000, and then because you want to exceed it, so if you get say 25.6, say if n is 25.6, then if you want to exceed that, then choose 26, round this up. So hang on, so set this to be 2000. We're trying to work out n in such a way that it would give us 2000. So that would then be n, which we're trying to work out, 2 times the first term, which is -8, plus n minus 1. We're trying to figure out n minus 1, and the common difference, in our case, the common difference is 5. So now it's just a matter of working out n now. So times both sides by 2, that will then give us 4000. And then now let's tidy up what's on the inside. So what's on the inside? 2 times -8 would be -16. -16. And then multiply this out. This times this would be 5n minus 5. Okay, 5n minus 5. So that would be 5n minus 5. Single number, merge them together. So -16, take away 5 will be -21. -21. So now let's multiply this out. This times this times this. I'm just going to put this in front. So it's 5n squared minus 21n. So now it's just a matter of solving this. So blindly solve this, turn it into a quadratic formula. Turn it into a quadratic where it equals 0, and then we can use a quadratic formula. So it's just a matter of finding n now. So take away 4000 from both sides. That will then give us this thing here. Now use a quadratic formula. Remember, the quadratic formula is, I'm expecting you to know this, plus minus root b squared minus 4ac over 2a. So this is your a here. This is your b here, -21, and this is your c here. Well, use a quadratic formula, and it will give you this answer, which I did it earlier. It gives you n equals. Don't forget, you're going to get positive and a negative version. You want the positive one because you don't really want a negative n. You want a positive n. So when you use a quadratic formula, n turns out to be 30.5-ish. So precisely when n is precisely 30.5-ish, it would give you a sum of 2000 earlier. But then you want it to exceed 2000. So your final answer would be n equals 31. 31 would then exceed 2000. Okay? That's your final answer.